So Barbara, time is 7:30 now.
And we've got a really great program that is scheduled. We're all looking forward to it. And without more ado, I will turn it over to Kyle Graham to handle the announcements.
Perfect. Here we go. All right, so welcome new members. If you're at the meeting tonight, see the Barbara or Doug about or Charlie about if they have your membership badge. Otherwise, they'll be at future meetings, and if you don't pick them up in a couple months, then they'll be mailed out to you. Again, welcome. There are donuts available. You should be able to find them out there on the patio. Upcoming star parties. The next ANSA star party will be September 28th. Astrophysics Special Interest Group is meeting at New Place on September 20th at 7 p.m. Orange Coast College, Building 40, the Astronomy House. Next beginners class is October 14th, and the next board meeting is November 10th. Check our website for all the information about these events. You should be able to find it on the calendar. Our outreach events coordinator is Martin Christensen. You can contact him at the email there below, outreach@ocastronomers.org. And these are our upcoming outreach events. We need volunteers for all of these, so please feel free to reach out to Martin if you would be interested in bringing your telescope out and helping volunteer at these events, showing kids the night sky. Just a reminder that our Adopt Scope program is continuing. You can find more information on the website, as you see here on the resources tab, then Adopt a Scope. You can download a sample adoption agreement. You can view the current inventory, and there's some really good information about how the program works there. The Serious Astronomer newsletter is always looking for new content for each month's edition of the newsletter. If you have items of interest that you would like to have put in there, please contact Dave Fisher at newsletter@ocastronomers.org, and he will review those items of interest. Please remember that in addition to the print format that everyone receives by default, the newsletter is also available online. If you would like to opt out of receiving a mailed copy, please let Charlie know. Just a reminder to everyone who uses the ANSA site to make sure to keep the site locked up, keep ANSA House locked up to ensure critters and unauthorized guests stay off the property and out of the ANSA House. Additionally, I think this should be pretty evident given the current wildfire situation, but please keep your pad and observatory areas clear of weeds, and please help out in the common areas when you have the chance to. A reminder that leadership elections are coming up. There are 4 officers and 7 trustee members. The nomination period closes at the end of the November meeting. We welcome if you're interested in running, please, assuming you meet the qualifications here, please run. We're always looking for new people interested in being on the board. If you're interested, you can contact any board member, or you can email Alan for more information about how to get on the ballot. Ballots will be in the December edition of the Serious Astronomer, and ballots must be received by the end of the January meeting. The next general meeting will be October 11th, and the WhatsApp presentation is next. Thank you.
Thank you very much, Kyle. So at this meeting for the WhatsApp, we have Lonnie from United Astronomy Clubs of New Jersey. Lonnie, the floor is yours.
Thank you very much, Reza, and it's a real pleasure to be here. We're going to be looking at what's coming up in the next couple of months, well, this month and next. And I look forward to doing this again in November. We're looking at the sky simulated in the free program Stellarium, which I'll mention later, at 20 hours, minus 12 is 8 p.m. OCA time on the 13th of September. That's today. And we've got the moon and the planet Saturn all lined up along the signs of the zodiac. Let's take a closer look at the events that are coming. I've marked the morning events for those of you who love to get up at 5 in the morning or 6. You can watch the moon pass some planets. But I'm going to start by focusing on 2 evening planets, Saturn and Neptune. Coming up on the 17th, the moon is close to the planet Saturn, and the moon will occult Saturn. That is an occultation from the word occult, hide or hidden or mysterious. The moon will pass in front of Saturn because the moon moves around the Earth pretty quickly. 29.5 days by phase, 27 1/3 days actual. But regardless, this is something that we could see at 4:11 a.m. It is an evening event, but you could consider that to be morning on the morning of the 17th. And you will look for it in the constellation Aquarius, which means that there's no relation between the moon, Saturn, and the stars of Aquarius. The moon and Saturn are much closer to us than the stars. We just say that these objects are in the constellation Aquarius because they're among those stars. Neptune is nearby. It's at opposition 4 days later, which means the Sun, Earth, and Neptune all line up. Both Neptune and the Earth are on the same side of the solar system. And you would find Neptune up here near Pisces, the same time as the occultation of Saturn. So I took the liberty of showing you what it would look like in a small telescope or medium telescope at 4:11 a.m. with its bright moon, the size of the planet Pluto, practically, Triton, easily visible in a small telescope. For the morning events, look toward the end of the month, September 23rd. The moon is passing Jupiter along this orange line. So go out tonight, look for the orange line, right? No, that's the Earth's orbit projected out into space. It's called the ecliptic, and it marks the signs of the zodiac. All 13 currently, not 12, as in traditional astronomy. The Earth has wobbled over a period of 24,772 years precession, and that changes where its orbit lies along the signs of the zodiac. Currently, there's an extra sign. But we look for the moon passing Jupiter in Taurus, and then between Taurus and Gemini the next night on the 24th, and then finally passing the planet Mars on the 25th. Very nice array. You want to see that again quickly? These are screen captures from Stellarium. Note the moon's phase growing larger, gibbous, or growing smaller, sorry, it's waning in the morning, from gibbous to thick crescent, passing Jupiter and Mars. Beautiful. If you can get up at 6 in the morning, do it. The full moon is also a supermoon, and it's also a partial lunar eclipse. We have a triple event on the 18th. Fantastic. This is what the moon looks like right now. I like to use Moon Giant to show us moon events. I do not work for this website, but I recommend it. You can see the moon's phases. We can make a nice calendar showing the principal phases, the names, the illumination level. There's a lot you can do. We note that the best time to see faint objects like nebulae and galaxies, gas clouds where stars are forming, galaxies, new moon, moon's out of the sky. Worst time to see faint objects, full moon, competing with street lights. Best time to see craters raking across the moon directly on the quarter phases. And you might even see city lights on the dark side of the moon. Not cities, mountain peaks. Each month has a poetic names for the full moon. I've chosen just one. the harvest moon, which happens to be a super harvest moon, pretty rare. And that's because the moon does not orbit the Earth in a circle. It's a squash circle. Mathematicians call it an ellipse. And when the moon is closer at perigee, apogee is when the moon is away, and perigee, P, is when it's pretty close. The moon's a little brighter, a little bigger, but not dramatically as reported by the major news media. Forget what they say. You can go to Earth Sky, oops, sorry about that, earthsky.org to get information on that. You can go to Wikipedia to get information on the lunar eclipse, which unfortunately for us here in California is not very well visible. You can catch a little bit at 7:44, the greatest eclipse. Since this is a partial eclipse, the moon is moving through the outer shadow of Earth, which is rather faint, the penumbra, and Nix, the inner shadow, the umbra. And so what you want to do is, if you can, at 7:44, if it's dark enough, see if you can note a little darkening on the top of the moon. And there's a nice simulator at timedate.com. You can slide the slider to show the progress of the moon through the penumbra. The autumnal equinox is happening on the 22nd, and here at 5:39 in the morning, the sun crosses the equator. We can't see it from here. I've marked both the Earth's orbit and the Earth's equator and the Earth's orbit, which intersect at the autumnal fall equinox, equa, days and nights, nox. The September equinox, 22nd. And here in New Jersey, we'll actually see it at 8:39 in the morning. The sun will exactly cross the equator at that time. Forget about the annular solar eclipse coming October 2nd, unless you're out here in the Pacific Ocean. I'm going to focus on the moon being near the planet Venus. Very exciting, October 5th at 19 hours, minus 12 is, audience, mathematicians. I have a friend who had a friend who was very annoyed that people would say, do the math when it's only arithmetic. He had a 170 IQ. Moon is near Venus, nice crescent phase, beautiful. If you use the free simulation program Stellarium, you can zoom in and out. It's like a living planisphere. And you can look in different directions, and you can look in close up to see what these things look like. Venus itself has a phase, gibbous phase. I'm going a little fast because we don't have much time, almost done. The comet C, very sexy name, C/2023 A3, easy to remember, everybody say it with me. Comet C 2023 A3 is at its brightest on the 12th of October, and that would be in the constellation Virgo. Virgo, big springtime constellation. So you can chart the comet's path. There are websites that do this. Very nice little navigator here. We're also going to forget about the occultation of Saturn that happens again on the 14th when the moon is near Saturn. And do keep an eye out at Corona Borealis, the northern crown, for the Blaze star, which has a reddish look to it because it's a double star, red giant orbiting with a white dwarf. Currently magnitude 10, we're hoping to see it brighten to visible brightness, magnitude 2, more than 600 times brighter. Every 5 magnitudes is 100 times. This is artwork by David Hardy, the oldest living space artist, who's recovering from a fall and a fractured vertebra at age 88. He's doing well. We've seen a brightening and dimming, just as happened in 1946. It happened again last year. We expect that anytime between April and September this year. So come on, T Corona Borealis, you're late. Look near the star Epsilon in the left side of the crown. And here in Stellarium, I've drawn it out and actually made a right triangle, just about a right triangle with Epsilon and the star above. It will be as bright as the stars of Cassiopeia. Nice bright magnitude 2. Got some references for you. These are still in print, Sky and Telescope Astronomy, for those of us who like to read on paper. You can also subscribe to their websites, and large parts of the sites are free. Free. I use them all the time. If you forget everything else I've said tonight, space.com, repeat after me. Space.com, easy, right? Got all kinds of news, space flight, search for life, and even some science. And if you like to use mobile apps, space.com has an article on the best stargazing apps. I counted 21 Android apps. I don't have an iPhone, but I do run Stellarium on my Android phone. Some of these are good for astrophotography. Some are good for just looking at the sky. If you don't like to download Stellarium, as I did on my laptop, or go online and use their supercomputers, which display like this, very intuitive to use, you can get it free for your mobile device. And with that, I'm going to say thank you for being such a good audience. You can find my free 3D globes that you manipulate with your fingers or any pointing device at astronomyinmotion.com. And I sell a Mars globe at 4K resolution and Mars at your fingertips. But there's a nice big HD version that's free with videos narrated by my wife, who I've never paid. Shameful. Thank you very much. And thanks to Razor for making this series possible. Oh, thank you thanks very much. I'm looking forward to Marta's talk. I am a big fan of fungi. I eat fungi. Don't know if I'd eat it in space, but I'm looking forward to hearing all about it. Thank you.
Great. Thank you very much, Lonnie, for an informative and entertaining talk. Looking forward to your next presentation in November as well. Great. Thank you very much. So now, without further ado, let's go to our main speaker tonight, who's a microbiologist and an assistant professor at the State Key Laboratory of Lunar and Planetary Science, SKL Planets, at Macau University of Science and Technology in China. Please join me in welcoming Marta Simões.
Thank you very much. Thanks for the nice presentation. Okay, let me start by sharing my slides. Okay. Can you see them properly?
Yes, all good.
Okay. So again, I'm gonna tell you a little bit about how fungi can actually matter in terms of space exploration. And hopefully you'll be addicted to the topic after this. Let's see. Okay. So, but before we actually start on that, I'm going to tell you a little bit about me. If I can manage to get this. Okay, there we go. So as Reza just said, I'm an assistant professor at Macau University of Science and Technology. This is a university located in Macau. Most people have never heard of Macau. Macau is located at the south of China, next to Hong Kong, basically. And I do research at the State Key Laboratory of Lunar and Planetary Sciences. So Macau has several particularities about it. It's actually a city of contrasts, let's say this. So it has about 710 million people in a small area of about 32.9 square kilometers. This makes it the most densely populated region in the world. But it used to be a Portuguese colony, so it remained under Portuguese rule until 1999. And there's still a lot of Portuguese influence that we can see on the city. So I'm showing here some images. You can see Portuguese influence on the architecture, on the streets. The names of the streets are still written both in Portuguese and Chinese characters, and you see it even on the food. But Macau is not really known for this. It's actually really known for its casinos. It's actually called the Asian Las Vegas. However, casinos here are slightly bigger than the ones in Las Vegas. So if you've been to Las Vegas, and if you've never been here, do come and just check the difference of scale. Okay, but regarding my work, so I do work in astrobiology, but because I work mostly with fungi, I work with astromycology, and I tend to focus on biotechnological applications, both clinical and environmental. Okay, and I'm going to start by telling you a little bit about astrobiology. If you already know about this, just bear with me a little. Okay, so astrobiology is the study of the origin, evolution, and distribution of life in the universe. It is an interdisciplinary field that combines elements of many different fields, from biology, chemistry, physics, but many, many others. It studies, of course, the origin of life by understanding how life emerged in our planet and how it evolved to become the diversity that we know nowadays. It studies life in extreme environments, so it studies extremophile, which are organisms that thrive in very extreme environments. And there are all sorts of organisms. You can have the ones that thrive in really hot temperatures called thermophiles, or the ones that like places with, for example, very low nutrients, oligotrophs, or the ones that like high pressures, piezophiles. So there's all sorts of different organisms. But of course, it also searches for the extraterrestrial life. This implies the search for life beyond our own planet. And for this, we look into particular things, like we call it biosignatures, which are signs of life, but they can be anything from patterns, from organic compounds, from fossils. There's all sorts of things that can actually be signs of life. And it also studies planetary habitability, which means that it investigates the potential locations beyond our own planet that can actually support life, like Mars, Europa, and exoplanets. And I'm pretty sure you know what I'm talking about, but still, just in case you don't. So Europa is the moon that orbits Jupiter every 3.5 days. It's an icy moon, and it's called this because it has an icy surface. But under its surface, it has a salty water ocean that we believe contains twice as much water as our own oceans all combined. Europa is just slightly smaller than our own moon, and it has barely 1/4 of the diameter of the Earth itself. Okay, and regarding exoplanets, those are the ones that orbit stars other than the sun, so they exist outside our own solar planet. Here I'm just showing an example of one, which is Beta Pictoris b, and orbits the star Beta Pictoris. Okay, but the major questions that astrobiology tries to answer are we alone? Is life on our planet just a coincidence? Are there any other places that can actually support life? And the thing is, these questions, they don't have a straightforward answer, a yes or no. So we need to check a lot of things, a lot of details in order to be able to come up with an answer. So how can we actually find answers? Well, there's many ways to contributing to finding these answers, but these are just some of them. By planning safer and sustainable missions, for example, and by guaranteeing the best conditions for crew members in spacecrafts, in future missions, and even in future bases. And in my case, I try to do this through astromycology. Okay, so if you're a Star Trek fan, then you probably heard of astromycology. This is a TV series that was released in 2017. And one of the main characters is an astromycologist. And I say is because the series is still going on. It's now on its 5th season. So this is the first time that astromycology became something that the public got aware of. But astromycology is actually a real science field. So it's at the interface between astrobiology and mycology, and it studies terrestrial fungi in space conditions. And no, there are no alien fungi, because some people ask me, so do you get fungi from Mars? No, I don't. Okay, and now let's give you some background on fungi. So when I speak about fungi, as soon as I say the word fungi or fungi, doesn't matter, or fungi or fungi, people tend to think about mushrooms. And yes, I understand I also like eating them, But fungi are much more diverse than this. There's all sorts of shapes and size. There are so many species. So much so that current estimates point for a total number of 13 million species alone on our planet. However, and this depends on the study that we check, we only know about 3.3 to 8% of these. So there's still a huge amount of fungi that we still need to discover. And one other fact that we know about fungi is that they are essential for the well-being of our planet, of terrestrial ecosystems. But regardless of all this, fungi are still overlooked, undervalued, and many times ignored, which is something that I have to say that I don't understand. And of course, working with fungi, you already know that I'm completely biased, but they can be carbon sequestering. They can be decomposers, and they are great at this. They can, yes, cause diseases, some of them complex, but they can also help us find cure for these diseases. They are edible, some quite tasty. They can eliminate pollutants. They can help in fermentation processes. Some of them are hallucinogenic. Some of them are actually rainmakers. Some of them are toxic. And if you've seen the series The Last of Us, then you also know that some of them can actually be zombie makers. So they are actually absolute marvels. And I don't think this is even questionable, but still. Okay. But even though they are amazing, they can cause serious issues. So they can be producers of mycotoxins. They can cause allergic reactions. They can cause, of course, spoilage and decomposition. They can cause several different infections, both in humans and animals, also in insects and in plants. And they are being now given a bit more relevance, so much so that the World Health Organization created this fungal priority pathogens list, and it kind of groups different fungi into highly risk species, high risk groups, and medium risk groups. So they are becoming more relevant, and people are getting more aware of their relevance, at least when it comes to the clinical side of the aspect. And when we think of them as our friends, they can do a lot for us, and they can be really good allies. So they can help in biotransformations, and it's because of this that we have products like bread or alcoholic beverages. They can be great producers of all sorts of metabolites, from antibiotics, antifungals, antitumorals, all sorts of important compounds. They can also be great enzyme producers, and this is highly relevant both for general industry as well as for food production. We can use their biomass directly. If you've heard about corn, it's one of the brands that sells mycoprotein. But they're also important for biological control of insects or nematodes, for forestry, agriculture, and they're also great producers of metallic nanoparticles, which is part of the work that I do with them. So they can be this great and this bad, and all of this is directly transferable to space exploration, but we'll get there. Okay, moving on. In industry, when you think of them, they have applications in all sorts of different industry. So of course, I'm focusing on space exploration, but all the applications that they have in all the different industries can also be transferable for space exploration. And they are so amazing that they even have their own kingdom of life. And more interestingly, they're the closest ones to our own kingdom. So they are really special organisms. Regarding my work, so I already told you that I don't work with mushrooms, but I work with a very specific type of fungi. I work with filamentous fungi, which are also called mold. It's what we usually know as molds. And these are called filamentous because, of course, they grow initially by forming these long filaments that you see on the image here. And when I talk about them, people don't really think of where they might be. And of course, these are just rhetorical questions. I don't expect you to answer me, but have you thought of where they can be? Have you considered that you might have some at home? And now you're saying, no, I clean every day. No, of course not. How about, have you considered that you might have them on you right now? And again, you're thinking, oh no, I showered today. What are you talking about? Well, I'm sorry to say, but you have them both at home and on you right now. And this is because filamentous fungi, they are everywhere. And this is literally everywhere. You can find them in soil, water, plants, animals, insects, everywhere. We even find them on our own Earth's atmosphere in air particulate matter. That's why they are referred many times as rainmakers. And we can even find them inside space stations. So we also find them in space. And the first time that we actually found them in space was at the first modular space station, the Russian Mir. So in this station, they started growing and covering all the windows and control panels, and they started to actually destroy them. So the station actually started malfunctioning because of fungi. And this was the first time that we realized that, well, space environment was not sterile as we thought initially. And we've actually found several different species growing there. But this is the aspect that we usually know. So when they grow a lot, enough for us to see them, this is what we see, this fluffy white thing on different food items, or black spots on walls, for example. So this is what we usually recognize when they grow enough for us to see them. But do you have an idea of how they look once we take them into the lab? So they have these amazing diversity. You can, when you grow them in Petri dishes, you have them in all sorts of colors, shapes, textures. And when you see them under the microscope, they're just beautiful. They have all sorts of different structures. Here, for example, these are just fungal spores. Okay, but why is it important to actually study astromycology? There are several reasons for this. So the first one is for planetary protection because of forward and backward contamination, and I'll explain what this is in a minute. And then second, because of fungal hitchhikers, because whether we want to or not, they're part of our human microbiome. So if we're going into space, they're going with us, whether we want it or not. But then we can also take them as part of our resources. And of course, another important issue is that we need to study astromycology in order to develop appropriate cleaning methods and disinfectants. And now you're thinking, but what? We already have cleaning products here on Earth. We can just take some? Yes, we can. However, if you think, for example, in space stations, the space station environment has microgravity. And if you just use a cleaning spray in there, the spray will be spread all over and it will go inside the human lungs. So that will be putting all the astronauts' health at risk. So we need to come up with different cleaning methods appropriate for these type of environments. And you might not have this idea, but a great part of the time of astronauts in space stations is actually scrubbing and cleaning the station to avoid contaminations, mostly of fungi. Regarding the forward and backward contamination, this is what we call when we have potential contaminations. If it's from taking something from Earth and contaminating a different place, we call it forward contamination. If it's the other way around, bringing something from outside Earth into our own planet, then it's backward contamination. But just think, if we go on a space mission, we take microbes with us, they change while in space, and then we return and bring them, we will be bringing backward contamination. So we really need to understand what happens to all the life that ends up developing outside our planet. Okay, and of course, we need to study astromycology also to guarantee safer future missions, to make sure that we avoid degradation and contamination of spacecraft, stations, and structures, so to avoid situations like what happened to the Mir station. And also because, for example, at the International Space Station, they had a lot of issues, especially in the rooms where astronauts used to do gymnastics, because in those rooms, the humidity levels increased a bit. So fungal contamination became an issue, especially in those rooms, because they had a lot of textile covering the walls. So fungi would just grow very, very easily in there. So we need to make sure that we avoid this, either by creating different cleaning products or different products to use on the infrastructures. And of course, we also need to avoid infections and diseases of the crew members. and make sure that we get sustainable missions. And this last point is really, really important, because one of the problems, one of the things that makes space exploration so expensive is the payload. So the higher the amount of payload that we have, this implies a higher amount of fuel. And that's what actually makes it expensive. So if we can just decrease the payload, then we'll need less fuel, then space exploration will become cheaper. And if you think, fungi can actually help with this, because when we go into especially the long-term missions, we cannot take an entire supermarket with us or an entire pharmacy with us, where we could, but it would be really, really expensive. So instead of this, just think, if we can take selected fungal species that produce medical drugs or that allow us to grow them and turn them into food, then we're reducing the payloads by a lot, making space missions much more sustainable and affordable. Okay, and then of course we need to study astromycology to understand what happens to fungi outside our planet. Because we already know that, for example, the human body suffers changes when it is exposed to outer space conditions. We have bone size decreasing, cell proliferation decreasing, so our immune system gets depressed outside our own planet. Just like our human body adapts to these conditions, fungi and other organisms also adapt to these environmental stress conditions. So we actually need to understand what happens, because they can change their gene regulation, their enzymatic activity, their secondary metabolite production. They can even become more pathogenic. So they can become more dangerous, but we need to understand what happens, especially because if our immune system is going to be depressed, this will actually favor any potential infections. So those are the main reasons why we actually need to study astromycology. And how do we study astromycology? Well, of course, we study fungal species from our own planet. So far, we haven't found any fungi anywhere else. Then we need to analyze fungal adaptations. And of course, we also exploit fungal species and their products for the space exploration, for example, to create improved infrastructures or improved materials. And regarding my own research, so a lot of the work that I do has to do with field sampling in analog environments. So terrestrial analogs, these are specific locations on our planet that are similar in some ways to extraterrestrial locations. And our planet is full of these extreme locations. There's all sorts of different environments that we can actually explore. So after sampling, what I do is isolation, identification, and the characterization of new species and new strains of fungi. So regarding field sampling, I've worked with different environments and samples from different places. One of them is salterns from Cape Verde, and Cape Verde are a group of islands next to the African coast. And here, there's several salterns in the different islands, and these are hypersaline environments that can be studied as Mars analogs. And this is because they are arid, high solar irradiance places with high salinity, increased temperature and oxidation, and they have unique organisms that are completely adapted to these conditions. This image here doesn't really show how beautiful this is, but this is a group of salterns inside an extinct volcano crater. But there are many different salterns in there. Some of them have these amazing and beautiful pink lakes full of different organisms. But then you also have salterns located close to city environments. So there's all sort of unexplored salterns in Cape Verde. But I've also sampled different salterns, also in Portugal, and salt lakes in Spain. And last year, I was for one entire month on a sea expedition at the Red Sea. So this was an expedition where we had people from all different areas of knowledge and from different countries and different institutions. And for this, we were collecting samples from the bottom of the sea. And we had to use a remote operated vehicle for this in order to get access to the samples, because these are at very high depths. So this is just a short video to show you the ROV going inside the water. Okay, and the top picture here, it doesn't really show, but it has it shows one of the parts of the ROV that is an arm that allows you to reach some of the samples and has sensors to check parts of the sample. So we collected different types of samples. We had cores from the bottom of the ocean with soil and sediments. Then we collected different types of water. And this is an equipment that allows you to collect water at specific depth. So it is a group of different bottles that have two openings, one at the bottom, one at the top, and they open when you're at specific depths, allowing you to collect water from specific depths. So we also collected some brine water samples. But regarding the hydrothermal vents, which is what we were actually trying to sample, these are sites that are located at depths higher than 1,000 meters. Here, the sunlight doesn't really penetrate. So the type of organisms that survive here, they are fully adapted to this condition and they are very different. So we ended up collecting several of these sites. And the last group of samples that we received in our lab came from Antarctica. So the astrobiology group leader stayed also 1 month at Antarctica at the beginning of this year and brought us samples from Deception Island. So after collecting all these samples and isolating all the different organisms, what we do with them, or in my case, what I do with fungi, is I expose them to conditions that are common to outer space environments. And this can be microgravity, which we do using a clinostat, hypergravity, high salinity, in the presence of artificial regoliths, which are soil simulants. We expose them to high and low temperatures and also study them under vacuum. So regarding altered gravity, we study them with simulated microgravity. For this, we use this equipment that rotates, has two different axes and rotates, simulating microgravity, and we get values that are very similar to what we find at the International Space Station. And we also studied hypergravity. And for this, we used a different equipment, which is a large diameter centrifuge, to simulate hypergravity. And for this, we managed to have access to the centrifuge through a program called HyperJazz. So HyperJazz is a specific program that anyone can apply to in order to have access to this equipment. It's a cooperation program between the United Nations Office for Outer Space Affairs and the European Space Agency. Anyone can apply. And if your project is selected, then you can have access to the centrifuge. I'm just leaving this here if you want to check information later on. So the focus on hypergravity, it's because hypergravity is what you usually find during launch and re-entry phases of the space missions. And it's basically intense acceleration forces that can be several times greater than our own planet's gravity. And of course, we are checking this because hypergravity has been reported as a biological stimulant for certain cells. And of course, if all microbes that are going with us on space exploration are exposed to it, then we need to understand what happens. And so far, no one actually thought about what happens to fungi. So that's why we came up with the project HyperSpaceX in order to detect potential risks and evaluate the fungal growth under hypergravity. So we had access to the centrifuge, and the centrifuge has these huge containers that are called gondolas, where we set a group of experiments with 20 different species to analyze what happened to them. And then we exposed them for 2 weeks to hypergravity. So we left them growing and developing on this centrifuge. Okay, so after all these different exposures, and keep in mind that we don't do this all at the same time, so these are different projects. I'm just trying to give you an idea of what we do. We analyze different things about fungi. So we check their morphological traits to see if they change morphology. We check their genetic stability to see if they are stable or if they change in some ways. In my case, I focus particularly on the production of metal nanoparticles, and these are particles that can be incorporated in products like textiles or cement mortars. And this is because they confer antimicrobial activity, so they can be really relevant. And I also checked their enzymatic profiles and their secondary metabolite profiles. So we check a lot of things regarding these exposed strains and species. And so far we found several interesting things. So for example, when we expose them to simulated microgravity, we found that if we check the production of silver nanoparticles, we get different shape patterns. So for example, in normal gravity, silver nanoparticles tend to be round. But under simulated microgravity, we found that the silver nanoparticles produced get different shapes. So they become triangle or square-like, which is very, very unexpected for us. We also noted that smaller nanoparticles are produced under simulated microgravity. And this is really important because in terms of antimicrobial activity, smaller nanoparticles have higher antimicrobial activity. So this makes them more interesting to study. We also studied fungal biofilm formation on Martian and lunar regoliths. And Martian and lunar regoliths, they're not rocks, so they're sort of like sand. So we wanted to check the formation of biofilm, but for this we need smooth surfaces. So we didn't have rocks, so we had to adapt. So what we did was we selected the bigger particles of the regoliths and we tried to get different particles so that the results were not biased, let's say this. And what we did was we embed them in resin, in epoxy resin, and then we polished the surface until we got a really, really smooth surface. And we put them on the bottom of Erlenmeyers and grow liquid cultures of fungi on top of them. And then we just observed to see if there was biofilm being formed or not. And what we actually found was that certain regoliths, so some of the soil simulants that we were studying, were favoring the formation of the biofilm. And then we also checked for total proteins in supernatants, and this has to do with the secondary metabolites and their enzymatic profiles, just to see if there were regoliths that were favoring this. And what we found was that there was a specific regolith, which is a moon soil simulant, that favored the biomass formation, the biofilm, but there were others increasing the formation of total protein. And this was for a specific species, Aspergillus niger. We checked the different species, but we also found the same soil simulant to favor the formation of biofilm. However, when we looked at the total protein, a different soil simulant, this was a Martian one, was the one favoring the production of proteins. So these are all still things that we're still trying to figure out exactly what this means in terms of the big picture, but we are seeing that at least soil simulants and microgravity, they have high impact on this. We also coupled the exposure of microgravity with the different soil simulants. And what we noticed was when we compared the controls with the exposure to the different regoliths, we had an increase in biomass. So if you compare the size of the colonies, they're much bigger here when you have the exposure to the soil simulants. And when you couple it with microgravity, with simulated microgravity, it doesn't really show here, but the colonies had more texture. They were higher in terms of height of the biomass. So there was also a bit more biomass being formed. And again, we tested the same two species as before, Aspergillus niger and Penicillium expansum. And it was more obvious for the Aspergillus species, but the same happened for Penicillium. We also did a different experiment using a large diameter centrifuge. So we checked the formation of silver nanoparticles because we wanted to see, so we usually test production of silver nanoparticles after exposing fungi, but we wanted to see what happens if these metallic nanoparticles are formed under the exposure of hypergravity. So we set up an experiment where we had a chemical precursor, which is what helps forming silver nanoparticles, added at 15 Gs under these large diameter centrifuge. And we tested 8 different species for this to see which ones were able to actually produce different silver nanoparticles. When we found two species, Aspergillus terreus and Fusarium solani, that produced a slightly higher amount of these nanoparticles. And then we compared them with the ones being produced at normal gravity. But we didn't really find many differences. So when we compared the different mycogenic synthesis, we found that there were no major differences. They had the same level of productions. So in the end, what this means is that considering that there was no such difference, these strains are actually suitable candidates for space exploration, especially if we would consider in situ production of silver nanoparticles. So this was just an idea to show you the sort of work that I do. I do other things. So these are just some of the publications within my group. But as an overview, as a final overview, what I want you to think of, and the message that I actually want you to retain is that, well, fungi are amazing, and they have an amazing diversity. They can be our friends and foes, and this is so true just on Earth as in space exploration. They are relevant, of course, under the space exploration, but they're still understudied. So we need more people thinking about them and doing research on them. And I do believe that astromycology is expected to provide major contributions to astrobiology, space biotechnology, Mars exploration, and space exploration in general, and also in situ research utilization. Of course, I don't do this work alone, and I always have to thank all the funding agencies and my research group, the astrobiology team at the State Key Laboratory of Lunar and Planetary Sciences, and these are just some of my collaborators from all different countries. And of course, if you want to know a little bit more, because I just told you a little bit of this story, you can reach out, contact me directly, or check this link because it has a bit more information about the work that I do. Okay, well, I hope you liked it. Thank you very much.